The average height of a freshman class of at least 5 students is 68 inches. A new student with height 74 inches joins the class. Which of the following is correct? And this is a multiple choice question where more than one answers may be correct. So you have to really examine all the options carefully. So we are given a list of 5 options, and 3 of those relates to how the new average height of the class may change, and the last 2 relates to how the new range of heights of the class may change. So let's start the problem by considering the number of students in the class before the new student joined as n. And it's worth noting that the problem mentions that n should be at least 5. So we can write this inequality that n is greater than or equal to 5. So the average height is 68 inches of the class before the new student joined. So we can write the sum of the heights of the class before the new student joined as 68 multiplied by n. So that's 68n. Now what happens when a new student of height 74 inches joins the class? Then the sum of the heights becomes 68n plus 74 inches, which is the height of the new student. So this is the sum of the heights after the new student joins the class. So that's 68n plus 74. And now, with the new student joining the class, we have a total of n plus 1 students in the class, right? So the new average height would be, therefore, 68n plus 74 divided by n plus 1. So we break up this by doing a little trick. So in the numerator, we break up 68n plus 74 as 68n plus 68 plus 6. So that's why we break up 74 as 68 plus 6. And then we can break this up as 68n plus 68 divided by n plus 1 plus 6 by n plus 1. And the whole idea of breaking this up is really to isolate the 68, because the first term, the numerator is essentially 68 multiplied by n plus 1, and the denominator is n plus 1. So the n plus 1 gets cancelled out, and we are left with 68 for the first term, and then 6 by n plus 1 as the second term. And from this, it is clear that the new average height will increase. It will be greater than 68, right? Because we have 68 plus a positive quantity, 6 by n plus 1. And that makes sense because the new student had a height that's substantially greater than the average height. So the average height will definitely increase. But the question is there any information, or is there enough information given in the problem to note or to make any conclusions on how much that increase is going to be? And this is where we start utilizing the inequality that's given, that n is at least 5. So that becomes important for this part. Now, if we add 1 to both sides of this inequality, the inequality is still preserved, and then we just change sides, and remember, these are all positive quantities. So when we change sides, this becomes 1 greater than or equal to 6 by n plus 1, right? And then if we add 68 to both sides, we have basically 69 on the left side, and the inequality becomes 69 greater than or equal to 68 plus 6 by n plus 1. So I'm trying to essentially bring the new average age on one side of the inequality. And if you notice this quantity here, that's the new average that we just calculated in the previous step. So the new average is less than equal to 69. So that's what this inequality means. And what it means is that the new average would be 69 or less, right? So that's what it means. So now if you look at the statement, the new average of the height was previously the average height was 68. So the new average could be 68 or could be the new average could be 69 or less, which means that the new average height of the class should increase by no more than 1 inch. So it should increase, but the increase should be no more than 1 inch, because if it's more than 1 inch, then that means the new average should be greater than 69. But this inequality says that the new average should be less than or equal to 69. So the correct option for this would be B. But then again, we are not done yet with this question, because this is the kind of question where there may be more than one correct answer, and we haven't really examined the ranges so far. So that's the options D and E, where we need to see if one of those options may be correct or not. So for that, let's remove all of these to make some room so that we can continue with the range. So what's the range of the class to begin with? Well, if the heights of the students are H1, H2, and so on up till Hn, there are n students to begin with. And then if the maximum height out of these is Hmax and the minimum height, the smallest height is Hmin, then the range is simply the difference of the maximum height and the minimum height. And the average height of the class, and this was before the new student joined, is given as 68 inches. So that implies that the minimum height should be less than or equal to 68 inches. The minimum height cannot exceed 68 inch, right? So at best it could be 68 inch, but expectedly should be lower than 68 inches. Now let's consider what happens to the range when the new student joins. So you have still the heights H1 through Hn, but now you have a new height, that's the n plus 1th student who joined the class. So that's the height of 74 inches. And since this height is 74 inches, the minimum height of the class will remain unchanged, because from the previous information we have concluded the minimum height is less than or equal to 68 inches. So if a new student of 74 inches height is added to the class, then the minimum height is not at all impacted, because the minimum height was already less than or equal to 68 and the new height added was 74. So there's no change in the minimum height. But we don't know yet how the maximum height would be impacted, right? So the maximum height, the new maximum height, that is, would be basically, depends on which is greater. Is 74 greater than Hmax or not? So Hmax was the previous maximum height of the class. So the new maximum height will be essentially greater of these two heights, 74 compared to Hmax, which was the maximum height of the class before the new student joined. Now we have basically two scenarios, right? So before that, let me just state here that the new range should be greater than, the height whichever is greater, 74 versus Hmax, minus Hmean. And Hmean is, like I said, the minimum height. It doesn't change because of the new student, right? So now we have to consider two cases. The first case is when Hmax, which was the maximum height of the class before the new student joined, that is greater than or equal to 74. So in that case, the maximum height of the class doesn't change as a result of the addition of the new student, and the new range is basically Hmax minus Hmean, which is the same as the range of heights before the new student joined. So in this case, there's no change in the range. However, if Hmax turns out to be less than 74, then the new range becomes 74 minus Hmean. And since 74 is greater than H max, right, in this case, so the range will increase. So this will be greater than H max minus H mean, which was the range before the new student joined. So in this case, the new range would increase. So for the range, we find that there is no definitive information given from which we can conclude that the new range increases. It may increase or it may remain the same. So the correct option or the best option when it comes to the range, the new range of the heights seems to be option E. So the correct choices in this case would be option B, which we have already shown. The new average of the height, the new average height of the class increases by no more than 1 inch, and option E, which states the new range of heights of the class may increase or remain the same.